Welcome to Geometry. In this course, we're going to be going through the textbook Elementary Geometry for College Students, 6th edition, by Alexander and Koberlin. I'm probably not pronouncing that right. Now, to follow along in the course, I would recommend you get this exact textbook. However, even if you have this textbook in a different edition, or even a separate geometry textbook, you can still follow along in the course and fully learn all of the concepts that are being taught. It's just if you don't have this exact textbook, you'll have to flip around in your own textbook to see exactly where the concepts are that are being taught. But any geometry textbook is going to have, in general, have the same exact concepts, just organized differently. Now, some of you might be currently taking geometry in college. Others might have tested out of geometry, and so the last time you took a geometry course was in high school. But no matter who you are, this course is very useful. So I know when I went through college in engineering, as I was going through school, I only remembered I tested out of geometry for college, and I only remembered some of the main geometry concepts, some of the main definitions and the main principles, like parallel lines and transversals. I remembered that, but I didn't remember any of the details. And just looking back at all of my engineering work, there's a lot of problems that involve geometry. Sometimes it's just basic, simple concepts, but even when dealing with basic concepts, it's nice to feel like you have more of a mastery of those concepts than just like a surface understanding of it. But even in some cases, it's not just an elementary geometry concept, it's more advanced. And in those cases, I wouldn't really know what to do. There were certain terms and definitions and concepts and principles related to volumes, angles and quadrilaterals and polygons, etc., things like that I either didn't know what to do when they came up, or for a lot of engineering problems, the geometry isn't explicit. You have to recognize the geometry contained within the problem in order to get certain variables, certain parameters that you need to solve the problem. So having that solid foundation in geometry can be really helpful. When working as an engineer in the workforce, one job I had as an engineer for a research team for John Deere sugarcane harvesters, my job was to oversee and run the hydraulic test facility. And what you realize is that there's so many geometry concepts that come up in a job like that, and really any engineering job. There's so many situations where you might need to see what an angle should be, what an area should be, there's so many different areas that geometry comes up, and it can help you to solve problems. Okay, so here's the outline of what we'll be going through in this course. The opening chapter, the course opens with studying relationships between lines and angles. But in this chapter, we're going to officially define, what is a line, what is an angle, and then from there build onto what are some of the fundamental relationships between lines and angles. Because, in general, that's the foundation of the majority of what we're going to study in geometry. Everything contains relationships between lines and angles, except for maybe with circles and arcs. That's not explicitly lines and angles, but when we study circles in Chapter 6, we're going to be drawing straight lines going through circles, the centers of circles, the passing not through the center, but still crossing over the circle, but not through the center. And there's more lines, and we're going to be thinking about angles between lines within circles. So we start by studying the basics of what a line is, what an angle is, and the relationships between lines and angles. That's where we start. Now, from when you last studied geometry, you might remember that this subject was a little bit different from other subjects in the sense that there was a distinct focus on definitions and proofs. Like what is the difference between a postulate, an axiom, a hypothesis, and everything went through these rigorous proofs. There were different types of proofs. Okay, well, As I've mentioned, this channel is not designed for math majors. I mean, if you're a math major and want to take the course, that's fine, but it's not designed for math majors. And so when it comes to like the official definition of a postulate, an axiom, we're going to learn a lot of that in the opening chapter. We're going to go ahead and read through all of that and discuss it. But as far as having a focus on it, working a bunch of example problems that are related to understanding those concepts, we're not going to go that deep into proofs and those types of definitions. We're going to be focusing on, definitions like what is a line, what is an angle, and all of the different purely geometrical concepts that you would use in something like engineering or some sort of applied mathematics. Again, I'm not a math major. I welcome a math major or PhD to comment on this, but it seems as though this idea of all of the proofs and the definitions that you learn that aren't exactly related to geometry, like axioms, postulates, hypotheses, that's not all unique to geometry. This is just a subject where a lot of that is taught. So the proof techniques, the analyzation techniques, the math proofs, math analyzations, I want to say that if you're a math major, you're going to use those techniques for all kinds of maths, right? The idea of an axiom, a postulate, that's not unique to geometry. You use those, you can make postulates about any math, algebra, whatever. And don't quote me on that. Maybe I'm misinterpreting that. Maybe all of that is unique to geometry. And again, I'd love a math major to comment on that. But yeah, we still are going to read through we're going to fully read through all of the sections. So in this course, you'll still get to see what geometry has to say about all of these terms and proofs, etc. We're just not going to be working, any kind of extensive example problems or do any kind of extensive focus on those concepts. Okay, so after line and angle relationships, we then study parallel lines. So that's when, you have parallel lines and they're cut by a transversal. Things like that. So what is the relationships between these different angles? Let's see, proving that lines are parallel. So yeah, maybe you don't know if two lines are parallel, but you have information about the angles, so you need to state officially that the lines are parallel. But you can see in this section they talk about the meaning of an indirect proof, and we'll read through that. But that's an example of you're learning about math proofs, math proof techniques, and so I'm sure you can use an indirect proof in calculus or whatever you need whenever you're doing in math. So for a math major, you want to understand exactly and work a bunch of problems on indirect proofs. But we're not going to do that. But we'll read through it. Okay. Then section 3, we start talking about triangles. So congruent, what makes triangles congruent? What are the different types of triangles, isosceles, etc.? Okay, chapter 4, quadrilaterals. So four-sided figures. What are the different types of quadrilaterals? The angles within quadrilaterals, relationships between quadrilaterals, etc. Okay, chapter 5, similar triangles. Similar triangles come up a lot in calculus, but even in engineering. Okay, chapter 6, circles. So there's all kinds of relationships with circles we want to study. Not just what circles are, but you can take a circle and you can run lines across it. Maybe the line doesn't pass through the center. Maybe it does. How do we understand what this angle is in relation to maybe the radius of the circle? Things like that. Or like an angle that has vertex at the center, what are some relationships between the radius, the diameter of the circle, or other features to different angles? Concepts like this can come up in more situations than you might realize. Situations in engineering, situations in your engineering job. All right, locus and concurrence, chapter 7. A locus is, you can have a locus of points. That just means it's a group of points that all meet some similar criteria. So a circle, the definition of a circle is it's the locus of points that are all equidistant from a point. all of these points share a common characteristic to where they're the exact same distance from this point, this what's called the center of the circle. That's like a locus of points. So we study different types of locuses of points. And concurrence is when you've got situations where lines meet at a common point. And that comes up in different situations. You could have like a triangle, and the lines that come up, that they bisect, there's equal angle on opposite side of this line coming from this vertex. They can meet at the center point of the triangle. And there's different properties about triangles you can learn by studying this. This is a concurrent point here. And there's other situations of concurrence of lines that we're going to study. Okay, areas of polygons in circles. So yeah, the area of any kind of planar shape that's in a plane, a polygon, multi-sided figure. That would be a quadrilateral, or have more sides than just 4 sides. And circles. How do we calculate the areas of those figures? What's the official way we can, you can look at any kind of shape in a plane and calculate its area. It's the area contained within the figure. Okay, now going from chapter 8 to chapter 9, it's a similar idea, but now we're talking about 3D shapes. And so 3D shapes are solids. They have surfaces. So what are the areas of surfaces of certain solids? Properties of surfaces, geometrical properties, solids, volumes of solids. What are the different types of solids? The different, you can classify different types of polygons in a plane, different shapes in a plane. Well, you can also classify different 3D objects, 3D solids. So what are the different types of solids? Okay, chapter 10, analytic geometry. So this is really algebra concepts, the graph of a line, the graph of a circle, coordinate systems. So we're probably not going to go through this in detail, but we'll still flip through this and just to see if there's some additional concepts that might be good to look at that maybe are a little bit different from algebra, or look at what we learned in algebra from a different perspective. And same idea with chapter 11, trigonometry. There's a full course in trigonometry, and so we're not going to go through this in detail either, but we'll flip through this and see if maybe there's concepts from trigonometry that that the textbook here presents from a different perspective. Okay, so yeah, that's what we're going to cover in this geometry course.